Yes, good morning, Joel.
Yes, good morning, Shelton.
I'm very fine. How are you?
I'm okay.
Okay, so we can resume with our training.
Okay.
So I'm thinking maybe from tomorrow. I can. There's another group that I'm training, so I'll be adding them to
Yes.
that we can have one big training.
Okay.
So I think you can see my screen at the moment.
Yes, I'm seeing it.
So the day before yesterday, we did an introduction of CCTV system. We did a basic knowledge of a camera.
Yes.
We're going to do basic knowledge of recorder. Maybe cover these two slides. And also, as per the certification requirements, you need to know, we need to cover these ones. So we have already covered the working principle. We need to cover recorder working principle. Then we do display. So we'll continue, we'll cover all this information.
Okay.
So today we're going to do recorder so that we go step by step.
All right.
Okay, I think we're going to begin now. So we're going to do basic knowledge. You can see the screen, yes?
Yes, I'm seeing it.
So for the basic knowledge of recorder, so if you remember from our previous discussion, the recorder is basically at the middle or the back end side. So you have the camera at the front end, then now we're going to have the recorder at the back end side. We do an introduction, we do a working principle, a coding knowledge. So you need to understand especially the coding knowledge and then information about trade and HDD. Then we end. The slide is not that much. So last time we did this front part here, the cameras here. So you can see today we are moving in this part here, the recorder. This side that is highlighted with the red. Next, we're going to do transmission, then at last video systems. Okay, so in the recorder side, you can see we have NVR, EVS, and the DVR. So DVR is used for the analog cameras, and NVR is used for the IP cameras. And you can see this EVS is a large storage. So these loads are usually plugged in with hard disk. Just an overview of this before we resume. So the working principle of a recorder is that just basically used for preview and playback, and they record the video information from the camera. So preview and playback involves rewinding videos of the cameras or checking the camera's live view, like you're going to see on the screen, the information, the picture displayed from the camera. So for an analog camera, you'd have a signal coming to the recorder. So the DVR will do analog to digital conversion, then it will do encoding and then storage. Then in an IP camera, the signal that is being transmitted is a digital signal. So you see, in analog, you need to convert the analog signal in transmission. So analog signal, you see this, the signal, this signal here is an analog signal, while this signal here is a digital signal because the signal has been converted from analog to digital here, from this point at the camera. So the main difference between an analog camera and an IP camera is, in terms of technical, is that an IP camera transmits encoded signal or a signal that is a digital signal, while this one transmits an analog signal here. So that's why you need to do conversion from analog to digital, then you do encoding, then you do storage. While in IP camera, you need the conversion and the encoding is been done at the camera. That's why you can transmit the information over a network. You can even view the information directly to your computer without having this end side here. So that's the main difference. So a DVR working principle. So DVR working principle, now we focus more of the DVR on the analog system. So DVR is suitable for analog system, connected with the analog cameras interface of coaxial cable. So the coaxial cable, like the cable for the TVs. So the DVR has to do a capturing of the video, has to do compression, recording, transmission functions, etc. So some also, you see from the DVR models can also connect with the network cameras. Like you see this, some of these models of the DVR can connect these IP cameras. They're called XVR. So it's a different kind of DVR. So you can use both analog and IP cameras on a DVR, which is called the XVR. So you define, when you're coming to talk about the models that we have for the recorders, you will get to know this model XVR here. And I think this is the current model that we are selling. So most of our recorders analog are XVR, which can support both IP and analog cameras. So this is just an overview, pictorial overview of what takes place. So analog camera, you can preview, coding compression. Maybe you can check with the time, but this is basically what happens at this point here. An NVR working principle is that NVR is connected to network cameras via Ethernet interface. So the network interface on the computer or the back of the NVR. So NVR has a recording, decoding, transmission functions. So recording is basically writing information to the hard disk. Decoding is conversion of the signal, or like interpreting the signal from the camera. Then transmission is more of setting information from one point to another. So we'll get to check this one later. So because the NVR does not support encoding, it cannot connect with analog cameras. So you understand this encoding here? Encoding is basically converting the signal to either analog and digital, or digital to analog. So that's why you can see from this here, from this DVR here, there is analog digital conversion, which is encoding, while this one does not have encoding anywhere here. So that's why you cannot have analog cameras connecting to the NVR.
NVR.
Yes. So any question?
No.
Okay.
I have no question there.
So you do about a bit of coding knowledge. We're going to talk about scanning models. That is basically I think I'll use an example for this to be easier. So you see, when a video is taken from the camera,
Yes.
or when a video is being displayed on the screen, there are methods of displaying those images, like images just as a series of lines so that it can form full images. So we have two kinds of scanning model. So we have something called progressive scanning, which is a format of storing and transmitting moving images with all lines, each frame are drawn in a sequence. So if you're going to draw an image like a picture here, for this picture, each line that form the image, you draw the lines in a sequence, like follow a sequence, so that at the end you have series of lines forming a full picture. Then if you're going to do an internet scanning, you would only do odd lines then of each frame, so that you're doing alternately. So internet scanning, like if you're instead of doing a continuous drawing of the lines for each frame. So I hope you understand by the time if I mean frame. Like if for a video is composed of frames. That's why if we say 25 frames per second, it means 25 pictures per second. And a picture is a frame, basically. And in those frames, it's a method of scanning, like creating those frames. That is progressive or internet scanning. In progressive, you do continuous lines. Internet scanning, you do odd lines first, or even lines first. Like you do 1, go to 3, 4, so that at the end of the day, you have only half of the numbers of actual images used to produce the video. So if from these two, you can guess which one uses less data, or it's less clear. So internet scanning. So in a video field, a field is one of the many images which are displayed sequentially to create impression of motion on screen. Two fields compose of one video frame.
One video frame.
Yes. So in a video, a field is one of the many still images. So a video is composed of still images which can create of impression of motion, going very fast. A video frame is composed of picture elements, just like a chessboard. Each horizontal set of pictures element is called a line. So you can see it's video frames, and then lines.
Lines, okay.
Maybe you can check later if it's not clear. You can check later. You can search
Review.
Yes. Different kinds of video standard. So while you see for an analog camera or an IP camera, especially analog camera, there are different kinds of video standard. Even if you are interacted with video devices, maybe aerial recorder. So there are different video standards that dictate which picture to be used on the screen. So you should also understand that a video standard is comparable with the power that you are using in your country. So like in Kenya, we use a video standard called PAL. The reason why we're using PAL is because our power frequency is 50 Hertz.
50.
Yes.
50 Hertz.
So our main power, like in the national power grid, is 50 Hertz, the frequency. Well, in other countries, the power frequency is 60 Hertz. They will use the video standard of NTSC. So the PAL is used in China, Europe, etc. So if you're going to install a device, you will check the video standard indicated. Like, it will tell you select your country, then the video standard will be selected automatically. So generally, when the frame rate is more than 25 frames per second, you use PAL, or 30 frames per second, you use NTSC, that is in US and Japan. So with this information, it's important to set this information because it can affect how the video looks like. So for you to achieve that real-time effect in the video, you need to have a good video standard. So network camera stream. So a stream is basically the video that is being sent by a camera. So the camera, the video that the camera outputs, that is called a stream.
Stream.
Yes. So we have different kinds of stream. The same way like a river. So a camera that is doing a recording will give you like audio. It might give you a picture, or it can give you a video. So that's why you could say audio stream or video stream. So it's basically the output from the camera. So some cameras model supports audio output, then it will have that stream.
Audio.
Some IP camera can give you more than one video stream in different resolution for different device. So you might be doing a streaming on your mobile phone. You might be doing streaming on your computer. So those are two different streams, but those are different streams, but the same video stream. So why do we need to do compression of images? So this theory here is more of we're talking about the functions of the DVR or NVR, including compression. So you understand this compression information. So basically, a video that is being output by a camera is very high. So we need to compress the video so that we can utilize the bandwidth in the network. And there are different methods of doing compression for the video. So how do you compress image data? We have a technology called H265. This one you will see frequently in so this H265, you will see it frequently while interacting with dark web products. And it's a technology that we use to compress the video, the image or the videos from the camera. So to reduce the size and to be able to utilize the bandwidth in the network. So to use the stream control technology, so as much as we are doing compression, we need to regulate this compression here. And the method that can be used to regulate this compression is either you do CBR or VBR. It controls the stream, like how the video is coming to us from the camera. It controls it. So it's controlling this stream that is coming here. So we can control it either constantly or we're doing variable. Take it later.
Variable.
Yes. In video encode technology, now we talk more detail about the H265 and H264.
H265.
Yes, the compression technology that's there, we talk about it. So H264 is an international standard. So how H264 works, it might be a little tricky to explain here, but you can later go and check it. So H264 will basically eliminate the constant aspect of a video. So like, for example, a video, let's say we are having a video with a lot of frames. So it will learn that from the initial frame, the house is not moving. Yes. So it will eliminate this information in the different frames, then use the frame at the last, combine the last frame and the first frame, so that the house appears at the last frame, while in between, it's not being repeated. So you understand? To compress. So the data for the house is removed in between here, but at the last part, it assembles everything now. So it avoids repeating information in the video.
In the video.
Yes. So you can see in the, if there's a small rectangle moves, H264 will not record the direction and distance, and the rectangle itself will not be compressed twice.
Twice.
Yeah, so it will not be compressing the rectangle every time. You can check this for technology later. So I've been talking about frames. You've heard me talking about frames per second.
Frames.
Yes. So frames is basically the pictures in a video.
Image.
Yes.
Yes.
So there are different types of frames that in a video. So we have iframe, P frame, and B frame. So an iframe is a complete image. Yes. A preframe is a predicted picture, and a B frame is a bidirectional predicted picture, which holds only part of the image information, the part that changes between the frames. So like an iframe here, this one is a complete picture, yes? A P frame, so because we are doing compression, this is the one that is moving, yes? So in this picture, this is the one that is moving. So it will predict that, this one is not moving and not compress it. To leave it. And then the B frame now by direction hold only part of the image information, the part that changes between the former and latter frames. So the B frame will be found between the last frame here, between the last frame and it will be behind the last frame, while P frame, it will be in between.
Between, okay.
Yes. So it will check with the last frame, then do compression. So it will realize that the last frame, what is changing is this one. There's a bit of confusion in this documentation, but I think maybe we later check it, but it might not be clear from this side. You can check this later. So, but the important thing is just know the compression technology that exists, that is H.264 and H.265. Yes. So H.265 is better than H.264 with high compression rate. Then we have even smart H.265 compression, which uses intelligent algorithm. So smart H.265 is for Dahua technology, and it's better than H.264. Yes. So H.265 plus, you can see it uses 10% of the hard disk, while 265 50, while 264 uses more. So it's important you understand this information while so that you know which compression to use in your hard disk. But the best is always use the current one, which is H.265. Now, stream control technology. So the way we control the video stream from the camera or the audio stream, we have different stream control technologies. So we have a CBR and a VBR. A CBR means that the stream will be controlled in a constant range, meaning that you are going to have your video stream or audio stream moving continuously. So the advantage of the CBR is that the stream is steady, and disadvantage is picture quality will go down if the video has a lot of. So like in terms of dynamic information, it means the scene is changing. There's a lot of changing in the network. So while VBR, it means the stream is variable. So depending on the situation in the environment, the video stream or the stream from the camera, including audio, can come in different ways. So advantage of this is that the picture quality is good, even if the scene is changing. The disadvantage is that the stream will be large and need more storage if the video has a lot of dynamic information. So you take like the stream will be changing. At times there is a peak time when the stream is high, at times the stream will become low in VBR, while in CBR you are maintaining constant stream. So let's do a bit information about hard disk and RAID technology. Introduction to hard disk. So we have different types of hard disk that we use in Yahoo products. So basically in our storages. So there's the PC hard disk, there's the surveillance hard disk, and there's the enterprise hard disk. So a PC hard disk is a normal computer hard disk. A surveillance hard disk is the type of hard disk that we'll use in our recorders. While enterprise hard disk is a type of hard disk that we'll use in high level storage or high projects. So in terms of capacity, we have different sizes, even up to 10 MB. In terms of sizes, we have 2.5 inch, 3.5 etc. So this is just a basic information. Interface, we have ITC, IIDE, SATA, and SAS. So you can see that's the hard disk for your computer. Laptop is a bit smaller. While the interface will be the same. So comparing hard disk comparison between the PC, surveillance, and enterprise hard disk is that. So normally, a PC hard disk, that is a computer hard disk, will require power more than 2 amperes. A surveillance hard disk will require power less than 2 amperes.
Plus 10.
Yes. And an enterprise hard disk will require a power of 2.8 amperes.
2.8 amperes.
In terms of warranty, a PC hard disk has a warranty of 2 years. So the important thing here is this working mode. So a computer hard disk will write more and read more and write less. So you'll be opening a lot of files in your computer. You'll be checking some documents. So that is the reading more. Well, you'll not be saving a lot of information into the hard disk.
Saving a lot.
So it's designed like to write more, to read more and write less.
Read more but write less.
A surveillance hard disk will write more. So the writing more comes in terms of saving the videos into the hard disk.
Saving videos, yes.
A lot, it will be focusing more on saving the video to the hard disk while reading less. So operation for the surveillance hard disk and the enterprise hard disk is the same. Yes.
No, it's not the same because this writes more and reads more.
Sorry?
I see the enterprise reads more and also writes more.
Sorry. Yeah. Writes more, read more. So you need to understand, if you're going to suggest products for surveillance, you need to use
for client
either surveillance or enterprise.
Surveillance, enterprise.
Yes. But enterprise might be costly, so you'd go for surveillance. Unless you're doing projects, go with
surveillance.
So avoid as much as possible using PC hard disk in your recorders.
Okay.
Video storage capacity. So your hard disk, to be full, it depends on the number of cameras that you're having in your network. So the higher the number of cameras in your network, the higher the video stream, and the higher the capacity, and then the storage will be less, it will take less time. So the storage capacity can be defined by manufacturers. So if you see 1 TB is 100 GB. So HDD capacity recognized by computer is, so if you're going to do a computer capacity, you'll have to use 1024. So 1 terabyte is 1024 GB, unlike the latter. So you understand this?
Yes.
There's usually this value here. So how do you know this?
Addition of 24 GB.
Sorry? It's not an additional.
Addition of 24.
No, it's not an additional. Like if you say 1
Oh, the
terabyte
manufacturer says it is
1 terabyte for computer is 1024 GB, not 1000.
Okay.
Yes. So how do you know the storage capacity? Like how do you know your capacity for that will be required? So total capacity is the required recording time and storage capacity per day. So if you say maybe per day you're going to use 2 GB, then times 30 days, you know which type of hard disk you need to purchase for to last that number of days. And how do you know the storage capacity per day? So you multiply the video channels, that is the number of cameras, times the video stream per channel, like which
video channels.
Each camera, what is the Mbps that is producing, times 60 seconds, times 60 minutes, times 24 hours. Then you divide it by 8 bits.
8.
So you're converting into this 1024. Yes. So if this 1024 is divisible by 8. Okay, we resume. So how to know the video stream per channel? So it's related to the resolution, bitrate, and compression difference only. So for example, you remember yesterday I talked about 4K different resolutions.
Yes.
No, the other day I said 4K.
There
is 4 MP. There is 920, 720.
Yes.
So this one is 1 megapixels. Yes. This one is 2 megapixels. This one is a 4 megapixels camera. This one is usually 8 or 12. So we have different versions of 4K. So if you're going to have like a 2 megapixels camera, the resolution is this. And the bit rate will be, if you're going to do 25 or 30 frames, usually it's 25 frames per second. Compression you use to set 265 for the camera. So it will require, the stream size will be 2 Mbps.
2 Mbps.
Yes. For 4K, it will be 8 Mbps. This is just a reference value. So how do you know the storage capacity? For example, you might have 16 channels. These ones are 16 cameras of 2 megapixels. Yes.
Cameras.
Yeah. 2 megapixels. Yes. So at 1080 camera, which uses H265 compression, has a bit stream of 2 Mbps.
2 Mbps.
A storage for one channel, that is one camera per day, is 2 Mbps times 60 times 60 times 60. Sorry, times 24 divided by 8. It will require 21
GB.
Yes. For 16 cameras, it will be 21 times
16.
21 times 16 will be 0.33 terabyte. So you can see how you can arrive to know how long your hard disk will last, or maybe so that you can suggest for customer. So if you do a recording of 4 days, if you're doing 4 recording days, so how long will a hard disk of 4 terabytes take? So we say 4 times 0.93 divided by 0.33. So you have 11 days. A 4 terabyte hard disk will last 11 days for 2 megapixels camera running continuous, like recording continuous. So for you to understand this, you might be coming later and be checking.
Okay.
Yeah. But there's a calculator for this. All this information, if you're going to the field side now, there's no need for you to do this calculation. There's a software I'll introduce you to, which calculates for you this. Yeah. So you don't need to worry.
Okay.
Yeah. RAID technology. So a RAID technology is a technology that is used in hard disk. So it is it's used to combine so basically what you'll do in a scenario where you have a lot of hard disk in a recorder, you can apply RAID technology to provide security, making also make the hard disk as a group, maybe make the hard disk as one, and record more faster and realize data redundancy, like the data will be secure. So we have different types of RAID that exist, but the main RAID technology that we use in Dahua is RAID 5 and RAID 10. So I think if you need to learn more about RAID, you can check it. You can be able to check these different versions of RAID, because it's something that's not Dahua technology, Dahua's technology, but it's a national standard. You can use RAID in anyone.
Okay.
So just an introduction about RAID 0, RAID 1. So RAID 0 is called Stripe. It combines all the hard disk and takes virtualization, but without redundancy, which make the whole system performance, but unable to afford disk or destroy of disk. So RAID 0 is basically information is stored at 1, 2, 3, 4 each hard disk. Like if you're going to have the hard disk 1, each block is treated independently. So information, there's no repeating of information. While in RAID 1, so the advantages of RAID 0 is that the capacity of the storage is the capacity of the hard disk. Okay? While in RAID 1, every information in one block is repeated in another block. So if you have information in block 1, it will be repeated in block 2. In this hard disk 2, in block 2 of hard disk 1, information is written there. So repeating of information, it means the capacity of this hard disk will be half the original size of the hard disk. The advantage of it is that in case one hard disk fail, you can still get information from this hard disk.
From this other hard disk, okay.
Yeah, but in RAID 0, if information is lost in hard disk 1, that information is gone, because this information here is different from the information from this hard disk. Yeah. Advantages of this one is that it's capacity. That this one capacity is big because it store more information, and this one capacity is less but more secure. So RAID 5 is the one that we use. So the RAID 5 works that in such a way that it provides function when one hard disk does not work. In case one hard disk fail in the group, like you're combining 5 hard disks or 10 hard disks, in case one hard disk fails, it will utilize one backup hard disk. There's one backup hard disk. So RAID 5 is the most common used RAID level. So how many hard disks will you require to achieve a RAID? At least 3 hard disks. So in RAID technology, RAID 5 is the most preferred, and it works better when the number of hard disks is odd. So if you have 3 hard disks, you can configure RAID. If you have 4 hard disks, you can configure 3, then use 1 as spare. If you have 5, you can use 5. If you have 6, you can use 5, then 1 as spare. If you have 7, you can do 5 plus 1, then 1 as a spare. So you understand, basically combining groups of 3 or 5 or 9 from here. If you have like 8 hard disks, you combine a group of 5, 3. Like this one is RAID 5 group of 5 hard disks, RAID 5 group of 3 hard disks.
Okay.
It's just a reference for when configuring RAID. Yes. So the comparison between different kinds of RAIDs, RAID 0 to RAID, you can see the number of hard disks. If the hard disk is greater or equal to 2, so if you're going to use RAID 0, utilization is 100%, like it will be the capacity. If you're going to use RAID 1, utilization is 50%, half of the hard disk will be used, the other one is just a backup. I think you can just take a reference later and learn more about RAID if you are interested in RAID.
Okay.
So common functions before we wind up this training for today. So common functions of recorders. So I think you're with me.
Yes, I'm with you.
So we were talking about this. So now we're going to talk about common functions of NVR and DVR. The RAID technology applies here. So you can see this AVS. These ones are hard disks. You see these ones here?
Yes.
So these ones are hard disks. You can apply RAID technology in these hard disks here. Even some NVR model supports having a lot of hard disk inside. You can apply RAID in that. Now we talk about common functions of NVR. So common functions of recorders. So we say the XVR can support a camera and IPC camera, analog camera and IP. NVR can support only IP camera. So we see if we say channel, it means the number of cameras the device can support. So video preview. So a common function for recorders, video preview. So you can connect the recorder with a HDMI cable or VGA cable to a display and view the video from the camera. So I think you understand the word video preview. So video preview. So the video preview comes in when you are. You can see the display here.
Yes.
You can see you connect to VGA. So this bottom one, VGA or HDMI. Yes. And if you're connecting analog cameras, cable come directly. Connect here. Cable.
There.
That. Yes. A video storage is a common function of recorders. That is storing of the information. So both the NVR, the XVR, and the DVR can store the video from the camera. Video playback is basically searching information in the hard disk. They already recorded information. So you understand by video playback?
Yes.
So that's the end for recorders.
Okay.
Yeah. So I think our training today will end then because there's another training that I'm going to handle. Tomorrow
it's okay.
Tomorrow we might meet as a group for both groups for training. That we have a number of people.
Okay.
Okay, can have a nice day. Thank you for your participation.
All right. And a nice afternoon too.
Thank you.
I can.
Yeah.
All right. Thank you.
Okay, have a nice day.
A nice day too.